In this video, we're going to take a look at the domain and range of a function. We'll just talk about those ideas, those definitions, recall what is meant by the domain of a function, by the range of a function. And then we'll look at ideas of odd and even functions. So the domain of a function f of x is a set of all real numbers that can be substituted for x and give us a real value for f of x, right? So when we think about the domain, really all we are thinking about is the set of allowable x values, right? So what x values are we allowed to have, right? There are some functions where the domain is all real numbers, right? So if the domain is if we have a domain from negative infinity to infinity, there are an infinite number of functions that it could be. One large family of functions would be polynomials. So polynomials, they are continuous everywhere. If you have rational functions, the things that kind of tend to give you problems are functions where you have a denominator. Remember, we're not allowed to divide by 0, so anything that would make a denominator 0, that would not be included in the domain of the function, the values that would make that denominator 0. If it's a real valued function, right, so it has a real value, anything that would cause us to have imaginary or complex numbers, those would not be in the domain. So if we have even roots, anything that would cause us to have a negative underneath the even root would not be in the domain. The range then is the set of outputs, right? It's the possible y values that we could get when we plug in different x values. The range, from my perspective, tends to be a little bit trickier to figure out. We have to go through and see a variety of things. We're trying to see what y values are we unable to get. And sometimes it's straightforward, but other times it's just takes a little bit more trial and error. So those are the ideas of domain and range. Those are things that I imagine we've seen before, you should have seen before in some of your algebra days. With other things with functions that we have are odd and even functions. So if we remember an even function, a function is even, so it's even, if and only if, right? So that's what the IFF will mean, if and only if. So a function is even if and only if f of x is equal to f of negative x, right? So that what that's saying is if you plug in an x value and then you plug in the negative of that x value or the opposite sign of that x value, you plug both of those things into the same function, then your output, the y value that's output, should be the same if it's an even function. And not only if it's an even function, but only if it's an even function. If you have a graph like that, then this graph is symmetric across the y-axis. And so when you reflect that, it will give you the same value when you go across the y-axis. So here is an example. F of x equals x squared plus 2. Let's verify that this is even. We're going to do that by plugging in the negative of x. So you have negative x and you're squaring it. When you square a negative, the negative is going to go away, right? So this is like a negative 1 squared times x squared plus 2, which is x squared plus 2, which is the original function. And so when we plug in the negative of x, we get exactly the same output. If you were to graph this, this is a parabola opening up. It has a y-intercept of 2. Has a vertex of 0, 2. Notice that if you go positive x this way and negative x this way, your heights, your outputs, are exactly the same, right? It's symmetric about the y-axis. So that's an even function. An odd function, a function is odd if and only if, when we plug in the opposite of x, then the output should be the opposite of what we get when we plug in x itself. So these functions are symmetric about the origin. So if we have f of x equals x cubed, let's verify this is odd. So we plug in negative x. In place of x. This is negative 1 cubed times x cubed. When you cube negative 1, it is just negative 1. So we have negative 1 times x cubed, which is the negative of x cubed. But x cubed is just f of x itself. So we have the negative of f of x. And so when we plug in negative x, our output is the negative of f of x. And so this, something like this, symmetric about the origin. If I go x units to the right and go x units to the left, the space, the y values should be opposites of each other. Right, so the y value up here, if that y value is 1, then the y value down here is negative 1, has the opposite value of it. All right. In our next videos, we are going to start looking at and reviewing some trig ideas. We will see you there.